Let's look at exponential functions and how their graphs are affected by transformations, as well as how their attributes are affected by transformations. So let's look at y equals 2 to the x. We're going to use this as our parent function right now. And then we'll look at y equals 4 times 2 to the x, y equals 1/2 times 2 to the x, and y equals negative 2 to the x. So here is a graph with all 4 of these functions graphed on it. The parent function is in black, and it has a horizontal asymptote at y equals 0. The parent function has a y-intercept at 0, 1. The domain for the parent function is all real numbers, and the range for the parent function is from 0 to infinity. Okay, our red function, y equals 4 times 2 to the x, is here in red. And this is a vertical stretch. So the horizontal asymptote does not change, but because we're stretching this function away from the x-axis, the y-intercept is now at 0, 4, and the domain and range did not change. Our blue function, y equals 1/2 times 2 to the x, is here in blue, and this is a vertical compression. So again, our asymptote does not change, but our y-intercept is now here at 0, 1/2, and our domain and range also do not change. Finally, we have y equals negative 2 to the x here in green, and this is a reflection over the x-axis. So our horizontal asymptote does not change, but our y-intercept is reflected over the x-axis and is now 0, negative 1. Our domain does not change, it's still all real numbers, but now our range is from negative infinity up to 0, not including the 0. So in summary, for vertical stretches, compressions, and reflections, if we have a function of the form y equals a times b to the x, when the absolute value of a is greater than 1, we have a vertical stretch. And when the absolute value of a is between 0 and 1, we have a vertical compression. And when a is less than 0 or negative, we have a reflection over the x-axis. Okay, again, looking at our parent function y equals 2 to the x, we'll also look at y equals 2 to the x plus 5, and y equals 2 to the x minus 3. Here we have a graph with all 3 of these graphed on it. Our parent function again is in black, and our parent function has a horizontal asymptote at y equals 0. And again, our parent function has a y-intercept at 0, 1, and its domain is all real numbers, and its range goes from 0 to infinity. So let's look at y equals 2 to the x plus 5. That's graphed here in red. And that is a vertical translation or shift up 5 units. So the horizontal asymptote does shift up. So now it's at y equals 5. Our y-intercept is also shifting up, and now it's at 0, 6. Our domain does not change, but our range does change. So our range here is from 5 to infinity. And now let's look at y equals 2 to the x minus 3, and that's graphed here in blue. This is a vertical translation or shift down 3 units. And our horizontal asymptote does shift down from our parent function. So now it's at y equals negative 3. And our y-intercept also shifts down. So now it's at 0, negative 2. Our domain stays the same. It's all real numbers, but our range changes to be negative 3 to infinity. So in summary, vertical translations of the form y equals b to the x plus d. When d is greater than 0, it's a shift up, absolute value of d units. And when d is less than 0, it's a shift down, the absolute value of d units. Okay, carrying on our comparisons by looking at our parent function y equals 2 to the x. We will also look at y equals 2 to the x minus 2 and y equals 2 to the x plus 4. So here we see all three of these graphs on the same coordinate plane. Again, the parent function is here in black and it has a horizontal asymptote at y equals 0. And again, our parent function has a y-intercept at 0, 1. Our parent function has a domain of all real numbers and a range from 0 to infinity. Let's look at the graph of y equals 2 to the x minus 2. That's here in red. And we see that this is a horizontal translation or shift to the right 2 units. Our asymptote does not change, but our y-intercept changes to 0, 1/4 because the function is shifting right. But our domain and range did not change. Finally, let's look at y equals 2 to the x plus 4. That's graphed here in blue. This is a horizontal translation or shift left 4 units. Our horizontal asymptote does not change again, but our y-intercept does because our function is shifting left. So now our y-intercept will be 0, 16. We cannot even see that on our graph because it's a little bit higher than where our graph goes. And our domain and range don't change. So for horizontal translations with functions of the form y equals b to the x minus c, when c is greater than 0, we're shifting left the absolute value of c units. When c is less than 0, we are shifting left the absolute value of c units. And just reminding you that b in all of these functions is always greater than 0. It's always positive, and b does not equal 1. So in all of these examples, we used the parent function where the base was 2, but this could easily have been any other positive number other than 1. So it could have been base 10. It could have been base 4. It could have been base 20. So any other base number that is greater than 0 but not equal to 1.